Good morning everyone, my name is Silvy from 1 IPA A, and today I'll be discussing about free fall. Free fall or free falling bodies refers to a downward motion of a body due to the gravitational pull without any external forces. There are three general equations for the vertical motion. The first equation is velocity equals to initial velocity plus the acceleration due to gravity times the times. While the second equation is velocity squared equals to initial velocity squared plus 2 times the acceleration due to gravity times the displacement. The third equation is displacement equals to initial velocity times the time plus 1/2 times acceleration due to gravity times the time squared. While the acceleration due to the gravity is equals to negative 9.8 meter per second squared. Early ideas of free fall. The first one, we have Aristotle, who stated that the two bodies of different masses do not fall at the same time. For example, if we have a feather here and we have a rock. Now in this diagram, if we are going to drop the feather and the rock at the same time, which will touch the ground first? The answer is the rock will touch the ground first. Why? Because here there is something you call an air resistance, which I represent using the dots, and the rocks has a heavier mass compared to the feather. Therefore, the lesser the mass is, the more force of the air resistance will slow down the object as it falls. This is why rocks will touch the ground first instead of the feather. While the second, we have Galileo, who states that two bodies of different masses fall at the same time. This time, I'll draw another diagram. Here is the feather, and here is the rock. But these two objects will touch the ground in the same time. But in here, I will also add a container. So this will be the second diagram. Now, why two bodies of different masses fall at the same time? This is because that in this container, there's no air resistance. So it doesn't matter which one is heavier. Therefore, both Aristotle and Galileo's statements are true. Next, we will do some question sample and I will be showing the solution step by step. Example number 1. A body is thrown upward at a rate of 15 meters per second. How fast is the body after 1.8 seconds? Let's type down the given first. First, we will write down the given. We have the given initial velocity is equals to 15 meters per second. And because the body is thrown upward, so the initial velocity is positive. Next, we have the time given, which is equals to 1.8 seconds. And now, we are asked to find the velocity. After we write down the given, we are now going to determine which equation are we going to use to solve this type of problem. Is it equation 1, equation 2, or equation 3? Let's take a look again at the given. There is initial velocity, time, and velocity asked. So we're going to use the first equation. We're going to write down the formula, which is v equals to initial velocity plus acceleration due to gravity times the time. Next, we will be substituting the value into the equation, which is v equals to velocity, which is 15 meters per squared, plus the acceleration due to gravity, which is negative 9.8, multiplied to the time, which is 1.8 seconds. And now we are going to calculate the value, which will give us negative 2.64 meter per second. And there we have it, the final answer for this question. Now, note that the velocity is in a negative form, so the body after 1.8 seconds is going downward. Next, we have example number 2. A brick from the rooftop of a building suddenly falls and reaches the ground within 2.5 seconds. How tall is the building? Same steps. We are going to write down the given first, wherein we have the time is equals to 2.5 seconds. The initial velocity is equals to 0 meter per second. And now we are asked to find the height. So h equals to question mark. Now, note that height is the same as the absolute value of the displacement. Now we're going to determine which equation are we going to use. Since it asks for the height, now we're going to use the equation 3, which is displacement equals to initial velocity multiplied to the times plus 1/2 acceleration due to gravity multiplied to the time squared. Now we are going to substitute the value into this equation. Displacement equals to the initial velocity, which is 0, multiplied to the time, which is 2.5 seconds, plus 1/2 times the acceleration due to the gravity, which is negative 9.8, and multiplied again to the time squared. Now we're going to calculate the result. Zero times 2.5 will equal to 0, so we'll just cancel this. So displacement is equals to negative 31 meter. approximately. Now, note that the height is equals to absolute value of the displacement, so height is equals to height is equals to the absolute value of displacement, which is negative 31, which height will become 31 meter. And there we have it, the final answer. Next, we have example number 3. A body is thrown vertically downward at a rate of 8.5 meters per second from a height of 10 meters. How fast is the body upon reaching the ground? We'll first write down the given. Wherein the initial velocity given is 8.5 meters per second and the height is 10 meters. Since the body is now thrown vertically downward, which means the initial velocity will be negative, as well as the displacement. So displacement will equal to negative 10 meters. And last, we are asked to find the final velocity. This time, we are going to use the second equation, which is velocity squared equals to initial velocity squared plus the 2 times acceleration due to gravity multiplied to the displacement. We will copy this and answer, paste. Next, we will substitute the value inside. So velocity squared is equals to the initial velocity, which is equals to negative 8.5 squared plus 2 times the acceleration due to gravity, which is negative 9.8, and multiplied again to the displacement, which is negative 10. We will calculate the value, which will give us velocity squared equals to 268.25. And in order to find the velocity, we are now going to square root the 268.25. So velocity equals to the square root of 268.25. which will give us the velocity equals to plus or minus 16.37, and the final will give us negative 16 meters per second. Now, why are we using the negative sign instead of the positive? It is because it states that the body is thrown vertically downward, so we're going to reject the positive, and the velocity will be negative 16 meters per second approximately. And here is the final answer for this question. And this will be all the lecture for this video. Thank you.